We will now use what we know about root finding to find the gross return for a BTP. A BTP is a contract in which you pay a price today. This price is basically decided by the market depending on demand and supply. And all the information you need to know about a BTP are written here. So this is a BTP 3% expiring the 1st of April 2014, which is in 1 year from now. 3% means that you will get a payment of 3 in 1 year. But because of the fact that you get some money every semester, we say usually that you are paid a coupon, what is called a coupon, which is 1.5 for every semester. And because there are 2 semesters before expiry of the BTP, you will get exactly the 3 that you see there. And all the computation that we are discussing as it is conventionally done are based on the assumption that there is a nominal capital for a BTP of 100. So a BTP, as I told you, is a contract in which you pay a price. You pay a price today, which is the 1st of April 2013. I may stress the fact that this is something you pay by adding a minus sign. You pay today 101.7, and because you paid, you will get the first coupon in 6 months and you will cash 1.5, and you will get a second coupon in 1 year from now, which is 6 months after the first payment. You will get another 1.5. On the top of that, you will also get back your original capital, which is by convention 100. So a BTP is a contract in which you pay today 101.7, you will get in 6 months 1.5, and summing all the payments that are done at the expiry date, you will get 101.5 in 1 year. So if you assume that the BTP is priced fairly, which means that what you pay today should be valued as much as what you will get in the future, then you have that what you pay, which is 101.7, should be equal to the discounted cash flow of what you will get in the future. Let me call it X for a second. So what's exactly this equation? What I paid, which is 101.7, should be equal to the discounted cash flows. So this is the sum of 1.5 times 1 plus r raised to negative 1/2, because negative 1/2 is negative 1 semester, and I will get my 1.5 in 1 semester, plus 101.5 times 1 plus r raised to the negative 1, because I will get the 101.5 next year. So this is an equation which can be rewritten, for example, as 1.5 times 1 plus r raised to negative 1/2 plus 101.5 times 1 plus r discount factor raised to the negative 1 less the price 101.7, and this should be 0 because I want the price to be fair. And this is exactly the equation that I have to solve in order to find the unknown, which is the interest rate R, which the BTP is paying. And of course, the interest rate the BTP is paying is depending on the amount of the coupons, on the structure of the payments, and on the price, in this case 101.7, that is paid. And now we go back to R in order to define such a function and to solve such an equation using uniroot. Solve an equation in order to find the gross return of a BTP. To do so, we have to define a function which I call gross here. This is a function of the unknown interest rate R and of the price P, which in this specific case was 101.7. And the value of the function is negative P plus 1.5 times 1 plus r raised to negative 1/2 plus the final payment, which is 101.5 times 1 plus r raised to negative 1. In order to find a solution of the equation gross equal to 0 using uniroot, I have to be sure that there is a root and I have to provide a bracketing interval. I can get both things plotting a graph of the function gross. So here I am typing curve gross to plot the graph in the interval going from 0 to 5%. And I am also plotting a grid so that I can more easily read this graph. So I can see from the graph here that the point on which I am clicking right now is indeed a solution of the equation gross equal to 0, because you see that corresponding to that rate, you get indeed that gross is 0. More importantly, I see from this graph where a bracketing interval is. Remember that a bracketing interval is an interval in which there is a unique solution, and indeed this interval is, for example, the whole interval that you see here, meaning the interval 0.5% or 0.05%, which is exactly the same thing. So if I type uniroot and provide the name of the function, which is gross, and enter a bracketing interval, for example 0.05, R is producing this output here, in which you see the root we are looking for, 0.01288, which is roughly equal to 1.29%. So if you buy a BTP expiring in 1 year and you pay today 101.7, you will have a return which is about 1.29%. Here you see some other information. I am commenting this one. Here you see that gross at the root that you have just found is taking a very small value, because this is roughly negative 6 times 10 to minus 4, which is a small number. And hence we are confident that this is a good approximation of the root of the equation that we were solving. And this is pretty much all I had to say about uniroot to find the gross return of a BTP. Thank you for your attention.